Hey everybody, welcome back to another con support video. This one is on comparing distributions. All right, so basically when you're looking at two data sets and trying to make some conclusions from them. So in this case here, the first problem, let's see if I can zoom in a little bit so you guys can see it a little better. The histograms below show the heights in meters of the tallest buildings in China and the United States. Which pieces of information can be gathered from these histograms? So you can see there are two histograms here, right? And it looks like you might need to make it a little smaller. There we go, so we can see both of them together. All right. So you got this one about China and this one about United States. They're all about the number of buildings here on the left, on the y-axis, and the height in meters on the bottom of the x-axis. Okay. This little thing means broken, so basically it doesn't start. It kind of jumps to 240, right? It jumps to 240. There's like a gap. It doesn't label everything incrementally. So, anyways, when you're looking at these distributions here, we're going to first look at each each thing that we're analyzing. Okay, so I would say each assertion, but I don't know if you guys know that word. Anyways, the unit in the United States has the tallest building of these two countries. So now we're just looking at the tallest building. Okay, so when we look at the tallest building here, here has a number of buildings, and here has the heights. Okay, so the tallest building would be the one that is farthest to the right on the heights, right? So the highest building in China is between 490 and 540. Okay, that's the highest interval that we have on the history. The highest building in the United States is beyond 540, right? So that means that the tallest building in the United States is taller than the tallest buildings in China. Right? So now we take a look here. It says the United States has the tallest building in these two countries. The answer is yes. We can see that. Okay. China has more buildings over 390 meters tall. All right. So if we take a look at this little dividing line, 390 meters, all right, that means that anything that's 390 or greater will be beyond this line right here. Okay. Because this is 340 up to 390, and this would be 390 and above. So all this is 390 and above, these three. So if we look at how many buildings occurred there, it looks like that's about three right there. If we go across, it looks like that would be about three. So that would be like three, maybe four, and then like that looks like it could be two, right? So it looks like if we're making our best estimate about kind of where things fall between 0 and 5, it looks like this would be a 3, this would be a 4, and this might be a 2. It's a little fuzzy, but I would go with that. So if this is 3, 4, and 2, you're looking at 7 plus 2 is 9. There are 9 buildings that are greater than 390 meters tall. And then when you're looking at this one down here, these are obviously ones, right? So when we look at 390 meters or taller on the United States front, you only have 1, 2, 3, right? So it definitely means that China's got more of these tall buildings. They don't have the tallest building, but they have more of the tall buildings. So China has more buildings over 390 meters tall. Yes, I agree. And those two statements are true. So we're going to say check it. All right, next question. This one says, this one says, at the Olympic Games, many events have several rounds of competition. One of these events is the men's 100-meter backstroke. The upper dot plot shows the times in seconds of the top 8 finishers in the final round of 2012 Olympics. The lower dot plot shows the times of the same 8 swimmers, but in a different, but in the semifinal round. Okay, so this is the time of the swimmers in the final round. This is the time of the swimmers in the semifinal round. Okay, which pieces of information can be gathered from these dot plots? Remember that lower swim times are faster. Okay, so in other words, if you have a time that's to the left here, right, it's going to be a quicker time, which means you're swimming faster. So it says choose all that apply. The swimmers had faster times on average in the final round. Okay, so when we look at that, we would have to kind of think about what the average final round time would be, right? And if you look at the distribution here, it definitely looks like they are more towards the low end, right, in the final round. So definitely it would make sense that, yeah, these three are lower than the lowest value in the semifinal round. And there's a lot more in this area here for the semifinal round than in the final round. So if you look at the average, it's probably definitely true that the final round was faster. So that makes sense. Okay. The times in the final round vary noticeably more than the times in the semifinal round. And if you look at this, right, everyone's kind of clumped together here in the semifinal round, right? And there's just this one person who's kind of a little bit faster, probably the person who won the race, right? And over here in the final round, we've got like kind of gaps, right? So it says the times in the final round vary noticeably more. I think that's very true. Right? There's definitely more variety um, in that final round. So I think both those are true. So yeah. Okay, before sending track and field athletes to the Olympics, the U.S. holds a qualifying meet. All right. The upper box plot shows the top 12 men's long jumpers at the United States qualifying meet. The lower box plot shows the distance in meters achieved in the men's long jump at the 2012 Olympic Games. Okay. Which piece of information can be gathered from these box plots? All right. So this is the one that is actually in the Olympics itself, and this is the qualifier round. All right. Choose all that apply. The Olympic jumps were farther on average than the US qualifier jumps. Well, if we take a look at this, right, this box plot, the median of the box plot is way over here. It's not the average, right, but it gives you a sense of kind of where the middle is, right? And it's way, way farther to the longer side than the US qualifier. So that seems like that would make a lot of sense. So I would say that's true. Okay. All of the Olympic jumps were farther than all of the US qualifier jumps. So were all of the Olympic jumps farther than all of the US qualifier jumps? Well, we don't, first of all, know who's who on these, right? We can't compare apples to apples with the same person. So just generally talking about, are all these Olympic jumps farther than the U.S. qualifier jumps? And you'd have to say, no, they're not, right? There's a lot of U.S. qualifier jumps here that are longer than some of these Olympic jumps, right? Like all these Olympic jumps that are over here, right, that fall in this range, are going to be less than this Olympic jump, right, than this qualifier jump right there. So that qualifier maximum length is definitely better than some of these Olympic jumps, right? So all of the Olympic jumps were farther than all of the U.S. qualifier jumps. That's not true. The Olympic jumps vary noticeably more than the U.S. qualifier jumps. Well, look at the spread there. You're going from 7.7 to 8.3. When you're looking at the spread in the qualifier, it's like 7.7 to 8. So yeah, they definitely have more variation, right? There's larger spread, larger range, bigger range. So that's true. And that's what I'd say is true. So all right, and the last one here, Minneapolis, Minnesota, and Portland, Oregon have very similar latitudes. Latitudes measure how far north or south a place is, which in turn affects the temperature. The histograms below show the daily high temperatures in degrees Celsius that were recorded during January 2013 in each city. Which pieces of information can be gathered from these histograms? All right, so let's take a look at these histograms and see if we can analyze this. It says on average, Minneapolis was colder during January. Okay, let's take a look at the two. So here we got the number of days, and here we have the temperature in Celsius. The number of scales seem to match, so we can just look at it pretty comfortably, and we compare these two. And so Portland is definitely on the higher side, and Minneapolis is on the lower side. So it says here, on average, Minneapolis is colder during January. Well, I guess the whole thing is related to January, right? Is that right? Yeah, this is all for January. So it says Minneapolis was colder during January. I think that's very true, right? There are some overlap, right? Where there are some days where they're the same, right? But in generally, there's more cold days here in Minneapolis and more hotter days in Portland. So yeah, you say Minneapolis is colder. That makes sense. Okay, cool. So I would agree with that. On any given day, it was colder in Minneapolis than in Portland. Well, do you know what days these things occurred in? No, you don't know what order they are. Right, so any given day, you could take for example, it could be true that the coldest day in Portland happened to be the hottest day in Minneapolis, or vice versa, right? So when it says any given day, right, you don't know what the days were and which is comparing to which. So it says in any given day, it was colder in Minneapolis than in Portland. Do we know that for sure? Do we know that Minneapolis is always colder than Portland? No, we don't, because there are these days that overlap, right? Here's temperatures from 1 to 4. Here's temperatures from 1 to 4. the lowest temperatures in Portland, okay, could be colder than the highest temperatures in Minneapolis. There are some that are 4 to 7, right? So because there are some that are 4 to 7, we don't know which day lines up with which day. To say that in any given day it must be true that Portland was warmer than Minneapolis is a flawed statement. So we don't know that because it could be the hottest day in Minneapolis that is also the coldest day in Portland. We don't know what days are compared to what days. So this statement is not true. The daily high temperatures in January vary more noticeably in Minneapolis. Okay, it says the daily high temperatures in January vary more noticeably in Minneapolis. Well, that's true because there's a larger spread of the data. Take a look, it goes all the way from negative 20 to positive 7, right? That's a huge swing. Whereas when you look at the data in Portland, it's more consistent. It's from 1 to, whatever that ends up, probably 13 or something, right? So this is a smaller spread of data. This is a larger spread of data. So it seems like these Minneapolis is less consistent, it varies widely, whereas Portland's more consistent. So if that's what it says, it's true. The daily high temperatures in January were very more noticeably in So this is very true because it's more of a variety in Minneapolis. So that's a true statement. And that's it. And that's how you do that. Hopefully it helps.